right, so this is where we left off yesterday. I see some nodding. Perfect. If you could get your calculators out, I want you to take a minute and calculate the quartiles for data set A. Practice using our calculator. How do I get data into a calculator? Stats, enter. Very good. Stats, enter. 10, 8, 4, 6, 5, 8. Yes, I already have it there. 2. You what? Hello, what? Huh? Why? So, what did I say about calculators? Go do it at break. Okay, so before, after school, or at lunch. She's gonna yell at you if I send you down there now. Thank you, Jennifer. All right, I am assuming some of you are fast typers. What did we get for the first quartile? We got 5. We got 5. What did we get for the second quartile? And Jade, what did you get for the second quartile? Yeah. What's it called on your calculator? 8, the median. Yeah, good. What was your third quartile? 9. Can I get a thumbs up if you also got those? Very good. And we know the IQR is what minus what? Good. 3 minus 1. 3 minus 1. So 3 is 9. 1 is 5. Our IQR is 4. Good. Very good. So we're going to do 3 things in quick succession because I want to get to our game today because that's the fun part of today. We're going to quickly review the connection between our measures of center and spread for socks. We're going to talk about how to calculate whether something is an outlier or not because we know how to identify my graph. How do I prove it's an outlier? We're going to talk about box plots. We have one more graph to learn. Are there questions on finding quartiles before we get started? No. Okay. So, see what we remember from last time. If my data, when I graph it, is nice and pretty and symmetric, I don't have any outliers, which measure of center do I use? Jennifer, what measure of center should I use if my data is symmetric? What's our default? Don't remember. Drew, the mean. Good. And Austin, what measure of spread goes with that measure of center? I didn't mean to catch you with a mouthful of food. I'm sorry. Samuel, can you help him out while he eats? Which measure of spread goes with the mean? We have 2. Which one uses the mean in its calculation? Oh. What'd you get, Andy? So this is not resistant. We want the non-resistant spread that goes with it. What measure of spread goes with the mean? Standard deviation. Why the standard deviation? Because the standard deviation uses the mean as part of its calculation. It's the data value minus the mean squared, add them up, divide by, yeah. Those two are tied together. Good. Which means my other measure of center must be for skewed data. The median, good, because this guy is resistant to outliers. Remains relatively constant even if we have extreme values in there. It's not going to shift that measure of center much. Good. Which means the other measure of spread must go with it. The IQ, I don't know why I can't draw Q's today, IQR. And again, that's why center and spread are at the end of SOX. We do shape and outliers first to get a feel for what our data looks like. And based on our shape and our outliers, we choose an appropriate measure of spread and an appropriate measure of center. Yeah. So the S and the O part of SOX helps you choose the C and the S for the end. Yeah. Symmetric, you're over here. Skewed with outliers, you're over here. Yeah. You only have to remember that for a couple of units because second semester we're primarily focusing on things that are nice, pretty, and bell-shaped. And so second semester we're over here all the time. Okay, so for identifying outliers, we have two rules. Why do you think we need two rules? Good. I have two different chunks. I'm dealing with symmetric distributions differently than I'm dealing with skewed distributions. I want that to apply my tests for outliers too. So we have two tests for outliers. The IQR rule should go with the median and IQR, the skewed guys. Yeah, because those values tie in together. The 2SD rule, SD is standard deviation, that should go with the symmetric guys. They tie in together. Yeah. So you choose your outlier test based on where you are. So for both of these, we're going to calculate a lower bound and an upper bound of where we expect our data to be based on our measures of center and spread. Yeah, based on those values. Where do we expect data points to sit? Things that fall lower than the lower bound or higher than the upper bound are outliers. They're too far from the measure of center for us to consider them standard data points. Yes? Not really. Not really. Domain has to do with what you're allowed to plug in. This has to do with what we would consider normal versus what we consider abnormal. It's still creating a range. It's just a different purpose. Yeah. And we're going to do it for both. It's just the formula changes because we have different measures of center and different measures of spread depending on whether I'm symmetric or skewed. Yeah. And the upside is that the formulas are kind of related to the name. It's called the 1.5 IQR rule because I am going to subtract and add 1.5 times the IQR to figure out where those boundaries are. I just have to figure out what I'm adding and subtracting to. Yeah? The 2SD rule is called the 2SD rule because I am going to subtract and add 2 times the standard deviation. Again, the question is, what am I adding and subtracting it to? For the IQR rule, for the lower bound, I am subtracting that from Q1. For the upper bound, I am adding it to Q3. meaning I am using the middle 50% of my data as the basis for the calculation, and then I'm giving an error bound out in either direction from it. Because remember, the interquartile range is how wide that middle 50% of my data is. Yes? For the standard deviation, is it supposed to be lower, lower? It is not supposed to be lower, lower. Thank you, Drew. It is supposed to be lower, upper, but after lunch, my brain is wanting a nap because I ate too much cereal for lunch. And I'm having food coma. The nice thing about the standard deviation rule is it's the same value for both. I am adding and subtracting 2 standard deviations from the mean. Starting in the middle, 2 standard deviations out in either direction. This we're going to see an awful lot of, because generally this is how we determine whether something is normal versus abnormal. When you go to a doctor's office and they tell you that your child is abnormal, it's probably because they're outside of 2 standard deviations from the mean for their age group. Yeah, 95% approximately of all people, all data values, should be in this range somewhere. So only about 2.5% are above and 2.5% are below. Almost everybody should be between. Ugh. Okay, so what we're going to do, talk about why we need to do this, and then do it. Give an example so you can see what the calculations look like, yeah? The first reason that we do this, because it's time consuming, is these values may be an error. They may represent an error. I made a typo while I was copying down people's survey responses. I made a typo when I was taking that raw data and entering it in a computer. If I'm measuring values with a machine, maybe I had it miscalibrated one day, and all the data values for that day are 5 bigger than they should be. Yeah. So identifying those outliers may be an error. You should go back and look at our method and make sure everything was working properly. It's not an error. It could indicate a special case or a new pattern, something we haven't considered before. We just talked about that visit to the doctor's office and your child being labeled abnormal, right? That normal distribution, most people are between 2 standard deviations, but those tails go out really, really far. So it's not totally unheard of to have someone that's way out here. They're just a special case. They're an exception to the rule. That can happen. Yeah, they may be part of a new pattern. We just haven't seen data up there before, and there's a new pattern emerging in my population. Yes. Yeah, except it's not 100's the middle, so it's like it's 180 to 120 in the outside, and I think it's actually 15 because their standard deviation I think is 15. Yeah, so 2 standard deviations is 70 to 130. Yeah, because we know that most people are going to be between 70 and 130. Being outside of that is a special case. It's not an error in the data. It just means you are uncommon. That does happen. The reason we need to pick them off is that we know these values can strongly affect the values of some of our summary statistics. And I don't want to exclude a value if it's not an outlier, right? So there could be a value in here that looks really big in my graph, but it turns out it doesn't meet that mathematical requirement. I shouldn't drop it from the data set. I need to include it. It's not an outlier. Yeah. Okay, so let's try that calculation. We have a data set, and we want to test for outliers using both rules. We're going to do it both ways. So I'm going to do the IQR rule here. I'm going to do the SD rule here. We'll start with the IQR rule. So if I want to find the lower and upper bound for my IQR, what two values do I need for that data set? Ooh, good guess. Not the max and min. Not the min and the median. Quartile 1, quartile 3. Because IQR is Q3 minus Q1. The lower and upper bound are based on Q3 and Q1. Yeah, I need Q1 and Q3. And don't feel bad, that's why I asked, right? So, how do I get Q1 and Q3? I see some of you doing it. Data in a calculator, run 1-bar stats. Yeah? Everyone should pick up their calculator and practice. I already have it in there because I've done it this morning. I see some people typing. Nancy, do you have a value yet? No? Does somebody at your table have a value yet? No? Yari, do you have a value yet? What? You're confused. Yeah, okay, so your data's in the list, and then you go stat, and you go over 1, and then you go enter, and then enter, 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 enter. And then you scroll down. And I think you mistypoed because those values are a little bit off of what they should be. So double check your data list. Yes. Stat, over to calc, enter for 1-bar stats, and then enter, enter, enter. And you scroll down. Very good. Yesenia, what did you get for Q1? Q1. 5. What did you get for Q3? 8. Perfect. Very good. Excellent. 5 and 8. So I know my IQR is the difference between those. So my IQR is 3. I can subtract in my head, yay. I'm going to set up my lower and upper bounds. So lower is Q1 minus 1.5 times my IQR. So 5 minus 1.5 times 3. And I get 0.5. I see some nodding. Do we have any data points lower than 0.5? No, there's no data on the lower end less than that. We have no lower outliers. That end of the data is fine. We got to check the other end. For the upper, it is Q3 plus 1.5 times the IQR. So 8 plus 1.5 times 3. And I see people staring at me blankly. Ricardo, did you get a value? What'd you get? For this one? What did we get? 12.5? Yeah. Good. Is there any data in our list bigger than 12.5? Yes. What is it? 24. Very good. 24 is an outlier. Yeah. Yeah. We don't have outliers on the lower end. We have one outlier on the upper end. We probably already suspected that because 24 is double the next biggest number. Next biggest number is 12. That seems like it's really far out there. Okay, now we're going to check it the other way and compare. For the standard deviation test, Chris, what two values do I need to run the standard deviation check? Close. I do need the mean. What am I adding and subtracting from the mean? Standard deviation, which is why it's a standard deviation test. Good. So 1 var stats, we should have that on our calculator. I'm going to rerun it. It is the SX. Very good. It is. And it looks like you got what I got, Jennifer. 6.3 for the standard deviation. 6.3144 something something. 6.6. Did anybody else get 6.3? Double check that I did. Did you get 6.3? Good. Okay. So that might have been a typo in your list, Jennifer. That happens. That's okay. I got 7.454545 repeating. I'm going to round that up to 7.5. That's okay. That was cute. Okay. So these calculations go faster. Lower is mean minus 2 times the standard deviation. Upper is mean plus 2 times the standard deviation. If you are typing the same thing over with one tiny change, if you hit second enter, it will pull down your last entry, and then you can just type over the minus and make it a plus. Your calculator is your friend. Okay, Bailey, did you get a value for the lower? Not yet. Did you get any of the values yet? Not yet. Ishana, what did you get? Negative 5.10. Can I get confirmation? I see some nodding. Yeah, very good. Very good. Valeria, what did you get for the upper bound? Valeria doesn't have an answer. Jaden, can you help your neighbor out? Did Jaden get an answer? Did anyone at the back table get an answer? 201. That sounds a little big. 20.1. Yeah, that sounds a little bit more reasonable. Yeah. 20.1. 20.1. On the lower end, do we have any negative values? No. So no lower outliers. Do we have values bigger than 20.1? We know the answer is yes. We have 24. 24 is an outlier. So both tests picked off the same outlier. What's the difference between the results of those two tests? I see a big difference. Anybody else see it? What do we see? I see Ivan nodding his head. What do you see, Ivan? Yeah. That range right there is a lot wider than this range here. This is a gap of 12. Exactly. This is a gap of 25. More than double that gap. Yeah? Why do we think that is?
Because mean standard deviation are not resistant to the outliers or skew.
Very good. We know that this data had a suspected outlier. We knew that there was a point that was way out there that's going to throw our data off. And these guys are not resistant. So having that 24 in the data set made this gap a lot wider because both the mean and standard deviation were heavily influenced by it. So if you suspect that there is an outlier, if you see something in your graph that looks funny, 9 times out of 10, this is the test you will use. Okay, so some good news for the AP test. If you are doing SOX, they say describe a distribution. compare a distribution. You're doing shape and outliers first. Outliers, you're just doing a visual check of your graph. You haven't even touched center and spread yet. Visual descriptors are enough. I see a point in my graph that's way off by itself. Yeah. The only time you need to do this is if they explicitly use the phrase identify any outliers, and when they do that, they will tell you which test to use. They will say, use the 1.5 IQR rule to identify any outliers. Use the 2 standard deviation rule to identify any outliers. So they are going to be very explicit when they want you to do this instead of just looking at your graph. Yeah? If they don't tell you to do this, your graph is enough. Yeah? Now for the bad news. I told you they were going to give you a formula sheet on test day, and they will. And it's covered in equations front and back, lots of them. These are not on there because the structure of the formula is built into the name, and they're assuming you remember it. So yeah, the upside is this is never a big hit on the test. So if you get to this stage and they ask you to do this test and you can't remember the formula, the name will tell you 1.5 IQRs is involved. Try something. You'll get a point for trying. Yeah. And the test is like 50% on the multiple choice and 50% on the the FRQs is a pass, right? The bar is low for stats to get a pass. Yeah. You got to get like a 50% across the board. So if you can't remember it, it's okay. Try something. Just don't leave it blank. Blank papers make the readers unhappy. Yeah. Okay, questions on outliers? You see shaking our head no. Okay. Very last thing are box plots. Show me your hand if you've seen or heard of box plots before. I'm seeing less than half of our hands going up. So this should have come up in like math 1 through math 3 when you did your stats unit. Not all of the teachers did what they were supposed to during the stats unit, apparently. So we're going to talk about what a box plot looks like. So box plots are our last type of graph for quantitative data. We use these for numeric data. Yeah. These graphs are based on a 5-number summary. And if you are astute and you observe carefully, you will notice that the 5 numbers in that summary, min, Q1, median, Q3, and maximum, are the last 5 numbers that 1var stats spits out when you do 1var stats on your calculator. So when you run 1var stats, it gives you the 5-number summary at the bottom. Yeah, we know how to do that. That makes us happy. We like that. So we're going to get our 5-number summary for example A. We're going to build the box plot together, and then I'm going to give you a minute or 2 in class to work on B with your small group. Yeah. All right, so let's start with this guy here. I need the 5-number summary. So I'm going to call it my 5-num sum. And let me check that I have that data in my calculator. I do. And I get a min of 1, a Q1 of 5, a median of 8, a Q3 of 9, and a max of 10. And you may want to check. I'm pretty sure I did that correctly. Two things. 1, label the numbers. I just did that up there. 2, write them in order that they would appear on a number line when you write them down. I cannot tell you how many free response questions I've graded on tests where those numbers are all over the place. Min, max, Q3, Q1, median. That is not the order they came out on your calculator. Don't give them to me that way. Put them in order. Okay, box plot. First, I need a number line. Number line needs to go from min to max, just like I was doing a dot plot. 1, 2, oh, I take it back. Let's do that below because I'm going to run out of space. Once our number line is drawn, we are going to put 5 hash marks above the number line where our 5 number summary values are. So a hash mark above 1, above 5, above 8, 9, and 10. Approximately the same size, at the same height, uniform across, 5 vertical lines above those numbers. Yeah. I'm going to label them because this is the first time that we are making a box plot. You do not have to do this. You will not see statisticians do this usually. This is just to help us while we're learning. But that's what those 5 numbers represent. Yeah. And it's called a box plot because we're going to make a box. That box is going to box off the middle 50% of our data, which sits between Q1 and Q3. That is the box part of our box plot. And sometimes this is called a box and whiskers plot, because the last thing we're going to draw is a set of whiskers from the quartiles to the edges. I'm hoping for at least half of you that's tickling a spot in the back of your brain that you've seen a graph that looks like that before. Good. We like this for a couple of reasons. One, these measures in the middle are resistant to outliers. So that middle 50% looks like it should look. It wasn't influenced by the outliers. It has to do with location. That's nice. Two, all of the numbers in that list are something I can quickly calculate by hand, even if I don't have a calculator handy. Because all I need is to sort my list and cross values off, right? That's something I can do without technology. The graph is something that's pretty quick to draw by hand, but it gives me the same information that a histogram does. This is just as valid as a histogram in terms of showing me shape. I get a little bit less detail. Histograms, I can make those boxes narrower, those classes smaller, and get more detailed with the shape. This is always going to be broad strokes. But if I'm in a hurry, this is faster, right? And the AP test is timed. So these are great. We love these. For this graph, symmetric or skewed? Skewed, heavily skewed, right? Half of my data is between 8 and 10. Half of my data is between 1 and 8. So the lower half is spread out over 7 values. The upper half is only spread out over 2. So that is heavily skewed. Left skewed or right skewed? Left skewed. Very good. Skewed towards the long tail. This is my long tail. Good. Very good. Questions on that box plot? Yes. So box plots don't actually care whether the data value is there or not. It cares about the spread. So we're marking important locations in the data set, not what data values are actually part of it. There is an exception, and I'm glad you brought that up. Sometimes when you have a data set like this one up here that had an outlier, what you will see is they will do what's called a modified box plot. And what a modified box plot does is a modified box plot is going to remove the outlier from the picture and write it off to the side. So this data set, the min is 1, the max is 24. Yeah? So I'm going to start a number line that goes from 1 to 24. Not the prettiest graph, but we'll go with it. And instead of making hash marks at 1 and 24 for my min and my max, I'm going to make hash marks at 1 for my min. And then I'm going to make a hash mark at the next highest value. What's the next value right before 24? 12. I'm going to make my maximum at 12. And then way out at 24, I'm going to make a little star. And then you'd see the other boxes where they exist if 24 were removed from the data set. So for a modified box plot, you remove your outlier and you rerun one var stats with the data outlier removed from the data set. And that's what these numbers are. That would be the 5-number summary for the data set without the 24 in it. And then you see a little star. So if you read a box plot, you see a star in it, they're telling you that's an outlier. You have outliers in your box plot. They're not super common, but sometimes you will see them on multiple choice questions. Every great once in a while, they'll pop up in the FRQ. Again, less common, but sometimes. Okay, did that answer the question? More than you need? Yeah, probably more than you needed. Okay, good. That is a good question. Off the top of my head, I don't remember. That was the big one, right, with the 24 in it. Stat, one var stat, list one. With the 24 in it, that guy's median was 6. Without the median, it would go probably lower because, right? But, well, no, would it? No, the median would stay this. Ooh, it would depend on whether it was an even odd or odd set. It might shift to just to like a half a notch. Right. Yeah, if it was an upper outlier, your max will shift inward. If it was a lower outlier, your min will shift upward. What was your question? It's not a common question. It's not a common question. Yeah. Of all the things we're covering, I want you to see it, but I wouldn't like panic. Okay, what I would like you to do is I want you in your small groups to do what I did for A for B, data set B. Box plot for B, I'm going to give you about 4 minutes, 5-number summary, box plot. I'm going to have one of you guys come up or 2 of you guys come up and put it on the board. Okay, let's go through this list of some of you are mine, some of you are not. Yes. Wait, what?
Do we include the medium too?
You do. You do. Yeah. Start with the min and then just everything from that list. What's up? Okay. Okay, so very first thing if I want to get data in is stat and enter. And then you're going to put data in the list, and that list looks different than that list. So to clear it, we go up and then we press clear, enter. Perfect. And then you're going to type list B into that list. Yeah.
For the 5-member summary, do you use these numbers?
For your, what I asked you to do now, yeah, you're going to do what I did for A with B. So you need to get those numbers in B into your list and find their 5-member summary. Yeah. All right, and then to get the calculated values, we're going to press stat again, and then we're going to move sideways to calc, and then we're going to press enter to select one var stats. And you put your data in list 1, right? So that's already set. We're going to go down to calculate and press enter. And you'll notice you see the first 2 numbers there. Your min is 1, quartile is 2, and then if you scroll down, it gives you the other 3 numbers for your 5-member summary.
So then now I do this.
We're down here in Boxplots, so you need to copy down those 5 numbers and then make a box plot for them.
So like
yeah, just like I did for the previous set. Good.
I put them in order of
Good. Smallest to largest, just like they'd show up on your number line. Good.
I'm also confused with how to plot the numbers.
So stat, and then enter. And see, your numbers are coming up in different lists. We want to be in the same list. So to get numbers in a list, 5 and then enter. And then 1, enter. And you just type a number, press enter, type a number, press enter, and it'll fill down. Okay. I'll come back, Eileen.
Yes. Okay, I put all these numbers in right.
And then stat, and then over to calc, and then enter.
Enter, and then it shows this.
And then you scroll down.
And then this is, okay.
Yeah, that's
right.
perfect.
I'm right.
You got it.
Okay.
Yeah, that's good. Did you get it on your calculator?
I just want to ask a question.
Yeah. What's up? So that's what that's called, the 5-number summary.
Yeah.
5-num sum. And it's this list of numbers. That's the short code for saying I want that list of 5 numbers.
How do you find?
So first step is to get that data in a calculator. So you're going to press stat.
I did it.
That is, oh, you're in the, oh, you're in there. Okay, so now you're just going to type. So 5, enter. 1, enter. And then just keep typing number, enter, number, enter, number, enter.
Numbers that are here, right? Okay. And then go to
okay, and then we're going to press stat again. And over to calc. Sideways. Yep, and then enter for one of our stats. And then you put your data in list 1, so it's already set up. Just go down to calculate and press enter. Yeah, and you'll notice the min and the Q1 are there. If you go down on your list, it'll give you all 5. So those last 5 values are your 5-number summary. Okay, Eileen, did you get it? Okay, so stat, and then over to calc, sideways. Okay. And then we want one var stat, so enter. And then you put your data in list 1. So we're just going to go straight to calculate and press enter. And you'll see those first 2 values peeking out. If you scroll down, it's those last 5. All right, who's got a plot that they want to show off? Who can come draw a box plot for us? I saw several people's hands going up. You two have both verbally participated. You two have not. Do you guys want to come work together to get our box plot up? Yeah. Come on up. Come on up. We'll have you and Yari work together. Come on, Ricardo. You and Yari. Yep.
Good, right?
Yeah.
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 All right.
Oh. There you go.
Okay, are you first? Are you doing this one first? A or B? I mean, yeah, B. B. Yeah, these numbers. Okay.
Good.
One's the minimum, correct?
I see a 1 in the list, so I think we may have missed our yeah, I think it should go down just one further. That's all right. And then here, let me turn on your eraser real quick. There. You just use your. Okay. There you go. Got the median. Where's Q3? Where's our max?
Hold up.
You don't like his handwriting?
No, I did. Just a little rough. I'm sorry.
Feel a little judgy today.
Sorry. Q1, Q3.
Where's the median?
Med.
Med. Ah!
No.
Ah, you touched the screen and it threw a tantrum. So let's no, that's okay. Let's go with what you've got up there, and we'll as a class fix. Because otherwise we're not gonna get to do our greedy trade game.
Wait, can I show you mine? Like this?
So yours looks different. Okay.
Yeah.
Okay, so let's double check because we've definitely got the min and the max, right? We agree with the min and the max. The question is what's going on in the middle. So what was our Q1 collectively as a class? 2. And that probably came because you missed the 1 right here, and so it shifted everything up for you, Ricardo. That's okay. That happens. Right? This is a learning opportunity. That's totally okay. So we fixed that, so we know this is here. Where is our median? 5.5. So the median's sitting here. Okay, and then where is our Q3? 8.5. So right here. Does that look like most of your graphs? Okay, so no, I am glad that happened. That was good, Ricardo. 1 data value, and look at how different that graph came up. That's an important lesson for us as statisticians because we're going to be playing with our calculators a lot. You need to double check that your list is the right length. Make sure that when you're typing your numbers in, if you have 10 data values, you end up with your last number in the 10th box. Because 1 data value can throw everything off. So thank you. That was good. That helps us learn an important lesson. Yeah, no, snaps to both of you guys. That was good. What do we see about that picture? What do we notice? It's symmetrical. Yeah, yeah. Which is what we expect. This is the data set that had a median of 5.5 and a mean of 5.4. They were right on top of each other. Yeah, that's exactly what we expect from symmetric. It's not tightly packed. That middle 50% is spread way out, but it is symmetric. It's just symmetric with a really big peak. Yeah? Good. Very good. Questions on box plots? No, good. You're going to get some practice with them today.